solve this problem wherein 1 mole of an ideal monoatomic gas is put through a cycle consisting of the following 3 reversible steps. So number 1, there will be an isothermal compression from 2 atmospheres and 10 liters to 20 atmospheres and 1 liter. Number 2, isobaric expansion to return the gas to the original volume of 10 liters with the temperature going from a certain temperature T1 to temperature T2. And the last step is cooling at constant volume to bring the gas to the original pressure and temperature. Now, what we're going to do here is we need to calculate T1 and T2. Okay? And we also need to calculate yung ating enthalpy. Let me just underline. Internal energy, heat, and work in joules for each step and for the whole cycle. So first, let's try to illustrate what's going on in this problem. So una, meron ka daw isothermal compression from 2 atmosphere to 10 liters. Okay, and let me highlight that as well. So originally, meron kang 2 atmosphere and 10 liters. So let's try to identify that point. So somewhere here yung ating 2 atmosphere, and then yung volume is 10 liters. Okay, so therefore around dito yung ating initial condition. So anong mangyayari? Yung ganyang initial condition, which is 2 atmospheres and 10 liters, magkakaroon tayo ng compression. So tataas yung pressure, magiging 20 atmosphere, and bababa yung volume kasi compression siya. So that will be 1 liter. So nasaan yun? 20 atmosphere and 1 liter is somewhere right here. Okay? So yan yung 1 liter and 20 atmosphere. So our abscissa here is volume in liters and the y-axis is pressure in atmospheres. So yun yung first step nung process. Okay, so let me just draw here a line to indicate that step. Okay. Now, we will be able to solve for the temperature at this point. So, tatawagin natin siyang T1. And yung temperature din dito sa point na to is T2. Okay? Now, the second step is isobaric expansion. So, isobaric expansion siya to return the gas to the original volume of 10 liters. So, magiging 10 liters ulit yung volume. But you will change the T. So, you will go from T1 to T2. So, let's illustrate that graphically. So, from T1 to T2, sorry, there's a mistake here. This should be T1 as well, right? Kasi pressure volume plot is an isotherm. So, constant yung temperature in this first step of the process. Now, yung second step of the process, which is isobaric expansion, to return to the original volume of 10 liters. So, ano mangyayari? Yung volume from 1 liter, babalik siya ng 10 liters. Okay? So, nasa 10 liter na siya. Isobaric expansion yan kasi nga constant pressure gaya ng nakikita nyo ngayon. At yung temperature from T1 naging T2 na siya. Okay? So, mayroong change in temperature. And lastly, yung letter C, cooling at constant volume to bring the gas to the original pressure and temperature. So, the original pressure is 1 atmosphere and then the original temperature is T1. So, what we are trying to do here is cooling. So, ibig sabihin, from T2, which is a higher temperature, magiging T1 ulit siya. Okay? And also, in that process, bumalik tayo dun sa initial condition of original pressure and temperature. So that is the whole cycle. Now, what we need to do here is to calculate both T1 and T2 and of course, yung ating change in enthalpy, internal energy, heat, and work, both for the cycle and for each of the steps. Okay, so let's consider each step one by one. Let's probably number yung mga steps na to. So, yung step na to will be 1, then this will be 2, and this will be step 3. Alright. So, let's go to step 1 first. So, step 1 says isothermal compression. So, let me go ahead and just write it here. Okay. And that is from 2 atmospheres and 10 liters to 20 atmospheres and 1 liter. Okay, so ang gagawin natin muna is to calculate the temperature at the first or the initial condition, no? So, ibig sabihin yung T1. So, ano kaya yung T1? Since we will assume here that it's an ideal gas, okay? So, did I put here ideal gas? So, yes, it's an ideal gas. So, therefore, we will be using the ideal gas equation. So, T1 is equal to P1 V1 over N times R. So, yan yung form for the ideal gas equation kapag yan naharap natin sa temperature. Okay, so let's go ahead and calculate T1. So, P1 is equal to 2 atmosphere. Yan yung original pressure. And V1 is 10 liters. Now, yung N, or the number of moles, sabi sa problem, 1 mole lang siya. And multiplied by yung gas constant. So, what unit of gas constant are we going to use here? So, since naka-liter atmospheres and moles naman tayo, then let's just go ahead and use yung 0.08205 liter atmosphere per Kelvin mole. Okay, and you will be able to get T1, magiging equal siya sa 243.72 Kelvin. Okay, so yan yung ating initial temperature. Now, at this point, we can also calculate yung change in internal energy and enthalpy sa step 1. Okay, so step 1, meaning you are going from this point up to this point, isothermal siya, isothermal compression. So, ano kaya yung change in internal energy? So, the change in internal energy will be equal to 0. Kasi nga, isothermal po yung ating process. Constant temperature. And the same with delta H. So, delta H will also be equal to 0. Okay. Kapag isothermal, kung maalala nyo yung derivation natin ng equation for work, so remember it's W equals minus nRT ln of V2 over V1. Okay, so that is our equation for work in an isothermal reversible process. If you haven't memorized this, you just need to derive that expression from our equations. So, doing this or substituting what we have so far, so negative 1 mole, and right now hindi ko nalalagay yung unit. Well, that's a bad idea. Sige, lagay ko na lang. So, 1 mole. And then, the R that we're going to use here is 8.314 kasi gusto nating ma-obtain yung work in joules. So, 8.314 is joules per Kelvin mole. Okay, R is 8.314. Temperature, na-calculate natin yon 243.72. It's ugly. Let me repeat, 243.72 Kelvin. Alright. Isothermal naman yan, so it's just T1. And yung Ln natin of V2 over V1. Ano ba yung V2? So, si V2, okay, it's 1 liter. And si V1 is 10 liter. So, that would be 1 over 10. So, ang lalabas na sagot dito will be 4,665.77 joules. Okay? Or if you wanna convert that to kilojoules, that would be 4.7 kilojoules. And kung matatandaan natin yung isothermal reversible processes involving perfect gases, sinabi natin na ang Q is just equal to minus W. So therefore, Q is minus 4.7 kilojoules. So let me highlight our answers using maybe green. Okay. So we were able to calculate the following. Delta U, which is 0. Delta H, which is 0. Just for this step, isothermal. Work is 4.7 kilojoules and heat is negative 4.7 kilojoules. The assumption here is that yung negative na heat, ibig sabihin nun is that heat is given off by the process. And kapag positive, heat is applied to the process. Ganon din ang gagamitin natin sa work. So kapag positive work, work is done by the system. Kapag negative work, baliktad, no? Pag negative work, work is done by the system. Pag positive work, the work is done to the system. Actually, let me write that down. Okay. Just to be consistent with our sign conventions. Okay. So, pag sinabing positive yung heat, ibig sabihin, surrounding nagbibigay ng heat to the system. Pag minus Q, baliktad. Yung system, nag-i-evolve siya ng heat into the surrounding. Positive work means yung ating surrounding ang nag-i-input ng work to the system. And negative work, ibig sabihin yung system yung nagbibigay ng work sa surrounding. So this will be our sign convention. In some textbooks and in some other contexts, baliktad yung kanilang sign convention. So sinasabi nila doon na ang positive work is system to surrounding, negative work is surrounding to system. So it's just your sign convention naman. So as long as you are consistent in using these sign conventions, wala kang magiging problema, and as long as you know how to interpret the signs. Now, because of this sign convention, kaya tayo gumagamit ng formula for work as, di ba, integral of negative PdV. Okay, but if we have a different sign convention for work, if yung kabaliktaran yung sign convention natin, so makikita mo sa textbooks yung W, positive integral of PdV. Anyway, so we were able to obtain the 4 values ng mga yung internal energy change, enthalpy, etc. Okay, and we also have the value for the first temperature, T1. But that's just for the first step. Now let's go to the second step. Okay, so the second step ay isobaric expansion. Okay. To return the gas, to the original volume, which is 10 liters. And then, in the process, yung T1 goes or becomes T2. Okay, so ano yung gagawin natin dito? Let's just show again the second step. So, yung second step is, so we're done with the first step. So, the second step is this. Okay. Mali pala yung aking color. This should be white. Okay, which is this one. Anyway, so isobaric expansion siya kasi nga constant si pressure. Horizontal line lang yung meron ka. And in this step, we are trying to return the gas to the original volume of 10 liters. Okay, this one. And in that process, yung temperature naging T2 from T1. So, ano yung gagawin natin? Well, we have to identify or compute what T2 is. So, ano yung gagawin nating formula? Well, you can use the ideal gas equation if you want. But since isobaric naman to, okay, you can use the relationship between temperature and volume na lang. Okay, so remember, according to Charles and Gay-Lussac's law, T2 over T1 equals V2 over V1. But if you wanna use the ideal gas equation, no problem. You can go ahead and do that for both points or conditions. But anyway, ang gusto nating hanapin dito is si T2, no? So, T2 over T1, and T1 we obtained that a while ago, 243.72 Kelvin equals V2, 10 liters, V1 is 1 liter. Okay? So therefore, makukuha natin si T2 bilang 2,437.2 Kelvin. Alright. Now, isunod natin yung delta U, delta H, Q, and W. So, starting with delta U, okay, isobaric yung process. So, kung isobaric yan, kung tatandaan natin yung mga equations natin in the previous lectures, ang gagamitin natin is simply yung integral of CV dt. Okay? Now, ano yung limits? So, yung limit dito, since dt yung in-integrate natin, so the limits are the temperatures, no? T1, which is 243.72 Kelvin, and T2 is 2,437.2 Kelvin. Now, by the way, CV here will be equal to 3/2 times R. Kasi, sabi dun sa problem, ideal monoatomic gas siya. Okay, so let's perform the integration. So, magiging CV is constant. So, diba, 3/2 R. So, lalabas lang siya. And then, yung integral ni dt is simply the difference. Okay, so, diba, this will become T, but the limits are 243.72 and 2437.2. Okay, let's just go ahead and expand this expression. 3/2 R. So, yung T, magiging difference, no? 2437.2 minus 243.72. So, we just applied the limits. And you're going to use R na equal to 8.314 joules per Kelvin mole if you want to obtain yung internal energy change in joules. So, let's go ahead and do that. So, if you take out your calculator, malalaman nyo na ang delta U doing this calculation will be equal to, I'll just convert it right away to kilojoules. So, that will be 27.4 kilojoules. Okay, kayo nang bahalang mag-convert. Alright? Now, let's do the same thing for delta H. So, sa delta H, it's the integral from temperature 1 to temperature 2. Paras lang dun sa internal energy change. But this time, it's Cp dt. Since ideal monoatomic gas siya, ang Cp value natin will be 5/2, okay, times R. Or, if you want, you can just remember yung, just an aside here, diba tatandaan natin na Cp minus Cv Okay? In terms of molar heat capacities, it's just equal to R. So kung yung CV natin kanina is 3 halves R, okay, so we have CP here minus 3 halves R equals R. So therefore, makukuha mo yung CP as 5 halves R. Okay, now let's go ahead and insert that in our delta H equation. So magiging five halves R integral ni dt from T1 to T2. So the same, no? Ang T1 natin is 243.72 and ang T2 natin is ano nga ba 'yon? 2437.2. Okay. And if you do this calculation, lalabas na ang delta H will be equal to 45.6 kilojoules. So right now we have a value for delta U, which is this, and delta H, which is this. Okay? So ano na lang kulang? Si work na lang, tsaka si heat. So for an isobaric process, okay, isobaric expansion or compression, but for that process, isobaric, ang W, kung matatandaan natin, equal siya sa minus NR delta T. So just have to consult your equations, which we discussed last time. So let's go ahead and substitute minus 1 mole times the value of R, which is hindi ko na ilalagay, just to simplify my writing here. And delta T is yung 2437.2 minus 243.72 Kelvin. So ang lalabas dyan, if you're going to use R na 8.314 joules per Kelvin mo and converting it to kilojoules, well, you will be able to obtain a value of work na negative 18.24 kilojoules. And lastly, alam na natin na for isobaric or constant pressure process, Q is just equal to delta H. Okay, so we were able to again compute for both the work and the, oops, di ko pala nasulat yung solution. Delta H is what? Yung 45.6, right? Kilojoules. So, yan yung ating change in enthalpy. Yan na rin yung ating Q or heat. Alright, so we were able to solve for these four properties for the second step. Now, let's go to the third step. The third step is cooling. At constant pressure. Okay? So, no, not constant pressure, but constant volume. Okay? To bring the gas to the original pressure and temperature. Okay, so let's go back to the graph and show what happened in step 3. Okay, so ito yung step 3 natin. It's basically cooling, right? From T2 to T1. Okay? And constant volume siya. So the volume here, the value of the volume will stay at 10 liters. And basically what happened here is we will be able to return the gas to the original condition or the original temperature and pressure. So anong gagawin natin? Cooling, right? So if it's cooling, there will be a change in temperature. So if there will be a change in temperature, we have to still use the expression or formula for delta U and delta H na integral ni CV dt, and the other for delta H is integral of CP dt. Okay, again, CV is 3/2 R. So, constant lang yan. And dt becomes delta T if you put there yung limits, if you will use the limits of integration, which are the two temperatures, right? But this time, yung temperature 1 natin, or the initial temperature is T2, and the final temperature is T1. So, babaliktad sila. Ibig sabihin, magiging 243.7 Kelvin minus 2437.2 nga ba? Diba? Yung isang temperature. Okay? So, remember, this is now, diba, ang ating change will always be final minus initial. So, this is the final. This is the initial. So, ang initial dito is a high temperature. And from a higher temperature, you will go to a lower temperature, which is 243.7 Kelvin. Okay, so if you do this, you will be able to calculate delta U as negative 24, sorry, it should be 27.4 kilojoules. For delta H, we will do the same thing. Integral of Cp dt from a temperature of 2437 to a lower temperature of 243.7. I think I forgot to include the limits here. 2437 to 243.7. Anyway, if you do this integration, so Cp is 5/2 R because it's a monoatomic ideal gas. dt becomes delta T, so the same thing, 243.7 minus 2437, and you will be able to calculate delta H here as negative 45.6 kilojoules. So let's highlight our answers. So we have delta U, we have delta H. So ang kulang na lang Q and W. But it's constant volume, right? Constant volume po yung ating process. So makikita mo dito, kung constant volume yung process natin, edi W equals 0. Okay? Constant volume. Kasi W is minus P dV. And dV will be 0, so W will be 0 as well. Highlighting that. And finally, yung ating heat, okay, is just equal to your delta U for an isochoric process. Kasi number 3 or step 3 is an isochoric process, constant volume. So therefore Q is whatever you obtain na value in delta U, which is minus 27.4 kilojoules. So highlighting our fourth answer here. So kompleto na yung heat, work, delta U, and delta H. But what we have so far is for each of the processes. Okay? So what I would like to do next is, let's compute for those four values or properties for the whole cycle. So, ang gagawin ko muna is I will summarize the whole thing. Okay, so summary. We have the first step, isothermal compression. The second step is isobaric expansion. Number 3 is isochoric cooling. Okay. Now, if you add steps 1, 2, and 3, it will add up to the whole cycle. So, yan yung ating pinaka-cycle. Okay, so ang gawin natin is, let's identify or summarize our values. Okay, yung mga nakuha nating delta U, delta H, Q, and W. All of this in kilojoules. Okay, so for the first step, isothermal compression, balikan lang natin. Very quick. So that's number 1, right? So these are the values that we obtain. 0 for delta U, 0 for delta H, and we have also for work it's 4.7, for heat it's negative 4.7. So ilagay lang natin yon doon sa nabuo nating table. So 0, 0, minus 4.7. Then here it's positive 4.7. And let's fill in the rest. Okay, so kung babalikan nyo lang, for the step 2 isobaric expansion, 27.4 yung nakuha nating delta U, 45.6 for delta H, 45.6 for heat, and minus 18.2 for work. And for the last step, we were able to obtain negative 27.4 for delta U, minus 45.6 for delta H. We have minus 27 for Q, and 0 for work. So, ang gagawin natin, since the cycle is the sum of the 3 steps, edi let's also get the total for all these values under delta U, delta H, Q, and W. So for delta U, kung susumahin natin 0 plus 27.4 plus negative 27.4, you will get a value of 0. For delta H, it's the same thing, 0. For heat, well, if you take the sum of all of this, you will obtain 13.9. And for work, you will obtain negative 13.9. So let's try to somehow interpret these results. No? So it turns out na delta U, delta H both are 0 for the whole cycle. Kasi kung titignan mo yung cycle, and let's illustrate that once again, show it dun sa graph. From an initial condition, it went to different processes, pero eventually, yung processes na yon mababalik pa rin sa kanya. Napunta pa rin dun sa initial condition. Kaya nga siya cycle. Now, delta U and delta H is what we call, sila ay mga state function. So, delta H and delta U are state functions. Ang ibig sabihin nun is that kung ano yung value at that particular state given yung pressure and volume or maybe some other variables, okay, magbabago yung value ng function na yun kapag pupunta siya sa ibang state. Okay? So no matter what kinds of steps will happen in between these conditions or states, okay, mahaba man or maiksi or ever, okay, no matter what the path is, ganun pa rin yung magiging value. Okay, you have state 1, you have state 2, you will be able to calculate the different properties regardless kung ano yung pinagdaan ng steps. Okay? However, si heat tsaka si work, these are path functions. Okay. Pabalikan ko lang yung delta H tsaka delta U. So, since parehas lang yung state nung initial tsaka final, okay, at the beginning of the process or the cycle and the end of the cycle, so parehas lang na yung state nila, ibig sabihin, parehas lang dapat yung value nung delta H and delta U kasi nga state function sila. But for Q and W, path function sila. So, depende yung magnitude nila sa kung anong pinagdaan ng step or process. Okay, that's why you still have a value. And another thing to look at here is that basically, yung value ni Q is opposite in sign of your W. Ang ibig sabihin lang niyan, whatever heat is supplied to the system, okay, siya yung ginawang work ng system.